So let's tell you a story while we're doing that.
All right.
Once upon a time, there was a language. Actually, it wasn't even a language.
That's weird.
Try not to go over any of your slides, but before there was no Go, and now we are a Go. So let's do that.
Sure.
So let's take a beginner's look at Go.
All right. So we'll start with some statistics. So give you an idea of what Go is doing right now. So in recent surveys, big surveys from Stack Overflow and JetBrains, they have got some data about developers language and tools preference. So when it comes to for example, if you look at Stack Overflow survey, Go right now is ranked as the fifth most loved language after Rust, Kotlin, Python, TypeScript. So you can tell people love doing Kotlin on Android, Python for web development, and TypeScript for probably for front development. And Go is also ranked to the third most wanted language after Python and JavaScript. And it's all matching what we know so far. Python is used for web development as well as machine learning as well. And after that, it's also a very highly paid technology. After Erlang, which is surprising, Scala. Some weird language, I have no idea what that is in culture. And JetBrains, they also have their own survey and found out that Go is quite popular and very promising. And as also matched the index on POE, which so far as Go has been consistently in the top 20 languages in 2018, and the highest was the 10th in 2017. So Go is a promising language. It's not probably as huge as Java, Python, C#, but it is gaining attention from people.
One thing that's kind of impressive about the history of Go is that despite being in that language of the beginners of languages, version 1.0 happened in 2009. So it is less than 10 years old as far as production Go code is concerned. So all of this movement has happened within the last decade. The three creators of Go are Ken Thompson, Rob Pike, and Robert Greismer. Ken Thompson and Rob Pike are the most well-known of those. They were both employees at Bell Labs, and they were instrumental in the creation of Unix. They helped to create the UTF-8 standard. I believe that Ken Thompson also is related to the creation of the C and D languages. They're heavy hitters. They've done a lot of stuff. They were hired by Google as distinguished engineers. Basically, they had the ability to take salary to be put out to pasture if they really wanted to. But they actually all got together and decided, we're really frustrated with C++. Like, the computing landscape has changed enough that that there should be a language that represents now in ways that languages that were made before multi-core processors, cloud computing, and that sort of thing were even thought of. So it started as a set of emails in 2007. It was open sourced in 2009. Version 1.0 happened in 2012. They've been doing releases about every 6 months since then. And in August, version 1.11 just came out with support for modules, which is the first kind of semantic versioning support that they're putting in. But yeah, it's been going kind of at a whirlwind pace, which has been pretty cool.
So you may ask, why do we need a new language when we already have so many options out there? So let's go back to history and see what happened there. Why does Google decide we need new language? So back in 2003, 2004, we pretty much reached the maximum potential of single processors. That we cannot get higher frequency above like 4.0 gigahertz. And at the same time, the only thing we can improve the processor performance is to add more cores to it. However, at that time, the options we have, such as C, C++, Java, C#, and Python, were all optimized heavily for single processors. So they do not necessarily take full advantages of the potential that multiprocessors or multi-core processor that can give you. So we decided that okay, and on top of that, web is getting more popular. More things are done in the web than the desktop. So we need a programming language that allows us to take advantages of multi-core processors and be able to handle multiple threads easily and get very little overhead when it comes to concurrency and parallel processing. So that's the main reason why Go was designed, is to handle the mass traffic on the web in the future. So one thing, the interesting thing for Go is that Go is very popular in China once after it's released. Does anyone want to guess why it's popular in China? It depends on the game. Okay, it's a good guess.
Native UTF support, or UTF-8 support, meaning that all Chinese characters are native supported in all of the programming? It's actually half right. You can give me a real.
So the real answer is so the population in China that has internet access is right now about 700 million so far, and most people access the internet through their phones instead of computers or desktop and things like that. So most of them also consume a lot of web contents. So in order to handle that, when you launch a website in China, you have to be ready for like say handle a million people's visit at the same time. So they need a technology that allows them to scale fast and to handle all those concurrencies at the same time. And Go is the best option they have there. So that's why Go is popular in China, because they need to be able to scale and handle a lot of traffic on the internet.
So what are some features of Go? We've gone over a lot of some of them. It goes quick, it compiles quick, it runs quick. Because it doesn't have a virtual machine or a runtime library, you don't have to worry about something existing on that form before trying to run it. So you're not going to run into .NET errors like you do with C# code or JVM stuff with Java, which is nice. It makes despite not having the virtual machine runtime library, the executables are surprisingly small still, which has impressed me over the time of writing code. As far as a programmer nicety, it automatically handles garbage collection despite being more of a low-level language. Well, it's kind of a mix of low and high, but it has some of the features of languages like C and C++, but without having the additional mental requirements of having to handle the memory yourself. So the automatic garbage collection in that way is a huge advantage of being able to take advantage of kind of higher level tasks without the increased mental overhead of having to think about that. And yeah, I'll let you maybe take a couple more.
Sure. So the next thing is, which is my favorite feature of Go, is that a function can return multiple variables or values. So if you can think of anything that you do in Java or C#, sometimes you need to have either use a global variable, you have to pass a complex object to the function in order to return all those values back to the caller. So having a function that can return multiple variables can allow you to simplify a lot of the overhead that you have to do with Java and C# and on other traditional languages. And another part is very simplified concurrent programming. So if you have experience in like C, C++, or Java, when you have to start a new thread, you have to create a thread, and you have to call thread start, and you have to call you have to also be ready for any exception that was thrown during thread running. So you end up with a very bloated code just to get the thread started and handle the thread at the same time. So with Go, all we need to do is write Go and call function, and that's it. That's fire up the thread, and you don't need to worry about anything after that.
It also does get more complicated, but you don't have you don't have to have it be more complicated than that.
But it's definitely much more simpler than traditional Java thread or CP thread. And the part is, awesome part is it has built-in testing and benchmarking package. So if you have experience with Java or C Sharp, you have to use like JUnit or like multi-tool testing, like all those things that you have to, the third-party libraries that you have to use to get your test running. With Go, test package comes with it, so you have the official version of testing package instead of any third-party dependency.
Yeah. Oh yeah, the way to do that is to just write. So like if foo is the foo.go is your file. Foo underscore test is your test file, and you can keep it right in there. And foo underscore benchmark is your benchmarking. And then when you compile, that stuff doesn't get tossed out into the compiled executable, but you still have the niceties of like programming side for you.
How does it compile quickly? I always hear the joke is Go is
there are a lot of tricks like in the compiler. I do not know the details exactly. One thing the compiler does is it forces you to write very efficient Go programs. We'll explain that later. And other than that, it also uses I believe a lot of conventions that the Go forces you to follow also will simplify the compilation process, such as file naming and such as like packaging, and module designing as well. So that all helps with compiler speed up. But I do not know exactly the main reason why it's fast.
That and magic.
Yeah.
Magic.
But just one thing. I can tell you something like my project right now has like 4,000 lines of code in Go, and it compiles less than 3 seconds. So hopefully they give you an idea of like how fast it is. Right. Question?
I mean, you said that it compiles quickly and doesn't have VM or program library. But it does have dependencies or dynamic dependencies, right?
Yes, it does.
So the footprint is comparable to Java. That's nice.
I'd say maybe even a little less because it doesn't have to deal with a virtual machine on top. But we don't have apples to apples figures in order to guarantee that to you.
All right, so we'll go into a little more details about the types, like in Go. So in Go, you have basically a lot of types. So you have like primitive types that all languages have, such as integers and floating point numbers in Boolean variables. And then the next part is instead of having a class, you have a struct. So if you have experience in C++, you know what struct is. Or if you have experience with C Sharp, it's the same thing in C Sharp, which basically is a collection of variables, and does not necessarily I don't know what to say here, but
yeah, there may be associated methods with the struct, yes, but there do not have to be associated methods with the struct.
That's good. That's the point I was making. And then the composite types such as array and map. And there is one more thing called slice, which functions similar to array, but it's a bit complicated. We'll not talk about it too much today. Other types such as like linked list or heap, anything like that, is going to be that you either have to use like third-party libraries or you have to implement your own data structure. So map and arrays are the map, slice, and arrays are the three like mostly commonly used types in Go. In addition, there's a function type, which allows you to take a function signature as a type. For example, if you write a function that takes an integer as an argument and return an integer variable, or return an integer and a floating point, something like that, that can be a type, used as a type. And when you make that a type, you can easily wrap that with other functions. Use that as a point, use that as an argument for other functions. So you end up having like functions wrapped around functions, This allows you to implement things like decorator patterns very easily. The next one is interface. So there's no polymorphism, like classical polymorphism, like you use in Java or C#, but there's an interface that allows you to have polymorphism and generics. Generics will hopefully be added in Go 2, but before Go 2 is actually released, we will use, like people mostly use interface to mimic generics like that. Last thing is pointer. If you have experience with C, C++, you know what a pointer is. So it's pretty much a variable that contains the memory address of another variable. So when you update this variable, the value of the pointer, you automatically update the actual variable that the pointer points to. It's a little bit complex concept. We will not talk this much today.
Yeah, basically our thought was if you've heard of pointers and understand them, it'd be patronizing for us to explain it to you again. And if you haven't, I don't know if we can do it in 5 minutes. So that was our strategy today.
All right, so now we're going to dive into some code examples and see how Go actually works.
We're showing this off in Visual Studio Code. That works pretty well for coding in Go, but it's not the only option.
So in this program, we'll start with introducing some primitive types and variables in Go. So this is a typical and simple Go program. You first declare the package what this file belongs to, and then you import necessary packages that you're going to use in this program. And every executable Go program has to have a function called main. And it has to be put in a package called main as well. And the program will start from main code block and execute as a traditional tree structure program. So in the main function, when you declare a function, you call the func main. It's very similar to many other languages. And when you declare variables, there are 2 ways you can declare it. You can either use something like var, which stands for variable, and you give the variable name, which is called I here, and you assign a value called, which is 19. It's an integer in Go. Or you can do something like a variable name with a colon and equal sign, which declares and initializes the variable. In this case, we're declaring and initialize variable x to 2. In the next thing, if we want to do any like standard I/O, the package we're going to use is called printf, which can be found in the package called fmt. So when we import the package fmt here, we are using this function called printf. And printf stands for print with format. In this case, we're just printing the value of, or in this case, we're printing the type of x.
The reason why we're doing that is because Go has implicit type conversion. It sees an int and it is an int. You don't have to call it one.
But it's implicit, but it's also very static because we'll demonstrate that part later. So why it's called a static type. And for example, I comment out this code. If we want to do something like C, we want to declare and initialize a variable called C, and we want to use x plus 1.1. 1.1 is a floating point number, and x here is an integer. And the compiler here will already complain to you about this part, telling you that you are implicitly combining a floating point number to an integer. And that can be a little unusual for people who, if you are used to like Java and C# that can do automatically like type conversion for you. In this case, Go does not do that for you. You have to either convert the integer to the floating number or make the floating number to an integer.
And you do that by just assigning it to a new variable.
So yes, so that can add a little bit of overhead, or you can do something like you can convert x to a floating point number by adding a type assertion there, which will allow this statement to be legal in Go compiler. And next part will be global variables. So if you want to declare a global variable that can be accessed by different parts of the function of the program, you simply declare it outside of the function. In this case, you do not need to put in any classes. You do not need to put in any coding blocks. You just declare it as a variable and assign a value here. And you can, any function can have access to this variable and assign number to it.
There's a different format for assigning multiple variables inside of one file, but it's harder to read. So we put this simple one.
Good question. So the access control in Go follows the convention whether or not the first letter of the variable is declared as uppercase or lowercase. So if you have your own package in Go, all the global variables that are declared with lowercase, starting with lowercase, will be considered as a private variable, which is only accessible within your package, and it cannot be accessed outside the package. And if you want to make the variable accessible to any packages outside, you have to make the first letter capital.
I think the same follows for functions.
Yes, functions as well. So for function is if you declare a function that starts with capital letter, it's available outside the package, but if it's lower letter, it's internal and private. Yes. So printf. So in FMT package, printf start with a capital letter P, and that allows us to use that function outside of the FMT package. And same with str string conversion, which is strconv. Yes. Yes.
So here in the module section where you're reporting to modules, I've seen that
I'm going to stop you because these are packages. Modules were just introduced, and it's still confusing for almost everyone who's learning Go.
Right. I'm one now, so
yeah.
you can please So what I was asking is, if you call some other function or other package in your code, and you define it, that's fine. But if you define a package in the code section, you don't call that function, then it will
Yes.
It's been, yeah. Well, yeah.
I'm pretty sure
it's even more annoying. Yeah, it's even more annoying than that. If you're a person who likes to declare variables in order to debug the value, if you assign a variable and you don't use it anywhere in your code will not compile. It will literally say, like up here, if you don't use I, you can't compile this file. Which admittedly, I am sometimes an assigned variable and see what it is type of programmer, and that has definitely caught me.
For example, I'm right now importing an IOUtil package, and I'm not using any functions from IOUtil, and
it's also because you don't have it installed.
That's true. Okay, let me see. There's other packages. I think there's IO or OS. That's right, OS is a package. And we can see imported and not used. So this is one thing that Go forces you to be efficient in your program, so you do not importing dependencies that you don't actually use, which reduce the compilation time. Okay, so we'll move on with this project, with this program. So the next thing is string operation. So again, there's no automatic type boxing unboxing, so you cannot, like say, when you do string concatenation, you cannot do something like you append a number to the end of the string. You have either convert the number by using integer to character, which is I2A back in the C language, and this converts the number integer 1 to a string representation of 1. Or the other way to do this is you use a formatted printing function that returns a formatted string for you. In this case, we are using this %d to represent the number 1 variable here to make the formatted string. So let's compile this program and see what happens. Where's my terminal?
There's some sort of yeah, and every time you type, you never type right.
So in order to run a Go program, you have two ways to do it. So you can either compile it to a binary file and then execute the binary file, just like we used to do in C and C++, or you can just call it Go run file name. In this case, the file name is called primitive. Just Go run primitive.go. Okay, so this is giving him it's his complaint about my bad coding.
Yeah, remember that declaring a variable and not using it? It's us.
Yep. So we have to, in order for us to, for this program to compile, we have to remove the variable I, and then we'll try it again. Good. Now we're getting some results here. So the first output we get is oh, I should add a new line here. Let's do it again. So the first output we got is an int. This tells us the type of variable x, which is an integer in this case. And next one, we did some global updating global, changing the value of global variables, and the global variable was initialized at 16, and later we updated it to 22, and we got new value of the variable. And the third one, we use the formatted string to get the to append the number 1 to the string that we wanted, and we got what we have.
GDG's number 1. Yeah.
Shameless pandering always works.
All right. Ross, do you want to go through?
Yeah, let's do that.
Do you have any questions about this program? All right.
So the next thing we're going to talk about is composite types. That's where we start talking about slightly more complicated things. So an array is basically an always fixed container with a certain type. So in this case, the array is 4 int objects that we are declaring right away. An array, once you declare it, that's the size. It's never going to be anything other than that size. So you have to deal with it. Because of that, a lot of people don't use arrays unless they're doing it for performance reasons, if they want to be interacting with the contents in it. So one of the things, so also this is a for loop. For loops are pretty pretty I would say, flexible in Go. There's no such thing as a while loop. A while loop is a for loop with an always true condition. So you're going to see a lot of for loops and no whiles because they don't exist. In here, we're just making a while loop and then going through the values of our array. So that it's just printing them out when we run the code. Maps are the next level up. So a map is basically a key value pair, but the key can be any data type and the value can be any data type. So, I mean, a lot of people usually use strings, but you can, like, I made one for a different presentation with, what are they called? The character values have their own data type, and so I used one of those, which was strange. But you can use anything. You can use int. You can use float if you really want. So here what we're doing is because maps can be added and subtracted from, we are adding some values to it. So we're using strings and ints as the values. We were thinking about being in a cafe. It is nearly October, so if we're do some mochas, pumpkin spice lattes, tea, hot chocolate. Then we realized first then we print out that menu. Then we realized the error of our ways and pumpkin spice should be hidden from everyone forever, no matter what people say.
You're just trying to keep it for yourself.
Yes, we're keeping all the pumpkin spice to ourselves. And we're removing it from the menu to stop the people that are picketing outside of our little restaurant. So we delete from our map the value pumpkin spice latte. One thing that's interesting is that regardless of whether or not pumpkin spice latte exists in your map, that'll still run. It actually, I think there's a return value from there that you can technically get. Because of the multiple return values, this is where this can be useful. For example, when you refer to a map, the first value is the value, but the second value is a Boolean value as to whether or not it exists in the map at all. And so there's some kind of clever things that you can do with looking for the second or multiple return types of different functions in order to see whether or not things have gone the way you expect, instead of having flagrant errors happen and then you having to deal with that after the code is already compiled. So yeah, what we've then done is make a different for loop and use the for range menu, which is basically the same as a for each loop. That for each loop then indicates the key name followed by the value so that you can see our lovely cafe menu and the approximate prices of our very tasty beverages that we are imaginarily providing here. So if you want, we can run the code. We'll probably see the results of that map first, and then pumpkin spice existing and pumpkin spice. There we go. So yeah, what we're seeing here is the top one is the way of just showing a map by printing the map itself. That is going to be kind of the default printing, and then this is us dealing with the map and giving it fun formatting because that's how we wanted to format it. So yeah, that's composite types. Any questions about those? There are also slices, but slices get more complicated. So.
So is it always the case, for example, for something like delete menu, right? Like, is it always going to be the case that it'll delete it from the actual, like the object, so it's like it has to like reference into the, does that make sense? Like, is it always going to be the case that's going to modify the thing and pass it?
Well, I mean, if pumpkin spice latte doesn't exist, it will do a whole nothing to it because pumpkin spice latte doesn't exist in that.
So I guess what I'm saying, what I mean to say is like, could you like say if I wanted to have like a copy of my map with like one value delete from it, so I didn't want to change the original, but I just wanted to do something
I mean, you just make two maps. I think you can copy a map to another map, and so that's.
So I just make another one.
Yeah, if I'm remembering right, when you copy a map, first you just get the size and the types, but not the contents, and then you have to put in the contents after, if I remember right. Do you remember? I think that's what happens, but consult your Go documentation online for details.
So the size of the array doesn't change, but you can delete an item.
Not from an array. An array is what it is.
No, but okay.
Yeah, you can assign different values to the array. Like the values themselves can change, but the contents and the types definitely cannot change. And I think that was for the purposes of, being small and nimble, because sometimes you don't need all of the other niceties that these other things provide.
So how do you create a variable?
Yeah, yeah. It's true. It's just the syntax gets a little bit more complicated. It gets harder to show on like 5 lines. So.
So if the member is not there in the array, does the compiler try to ignore it or close it?
Say that again.
You mean in the map?
In the map, sorry. Yeah. In the map, if for example, if you delete it and delete it again, will it silently ignore the next delete or?
Well, like when we're trying to delete from the map, we can delete it 7 times. It will delete it the first time and then do nothing. What it will run, but what it will do if you're looking each time is it'll basically give you that second value, the second value would be whether or not it was successful in doing the deletion. Yeah, basically. Yep. Yes, I believe you could communicate whether or not the value was deleted if that is important to the business function or whatever.
What does that actually return?
Let's look at it.
Yeah, let's look at it.
Okay.
I think delete might actually just return a Boolean, but I'm not 100% sure.
I don't know if you use Go or use
Oh yeah. It's our way of showing off that we are not beholden. We're trying to provide information.
We're going to call headquarters.
Yeah. It's in the spirit of collegiality and information sharing.
This is DuckDuckGo is bad.
See, this was a.
Have to use Google.
Yeah. This is a backwards advertisement for the. We got you. We got all of you. Wait, what?
You stay.
Okay, so it still gives me this one. Okay, so delete. There it is.
You guys ever say that you can't Google search Go? How long does it go like?
Yeah, again, like I mentioned it before the talk started, but I consider the LANG in Golang to be silent. So I just call it Go, but when I look for it, I spell out Golang, and then I get the right results on Google, and everybody seems to be happy.
So delete built-in function deletes elements within Go specified. Oops.
Well, there we go.
So that's the source code of the delete function. If the map is null or there's no such element, delete is a no op, so no operation.
Oh, so it actually just doesn't do anything.
Yes.
So it sees it there, but it just doesn't run.
It compiles, yes.
It doesn't yell about it.
It doesn't.
Right. I think the reason why is because the value of that key for the map isn't always known when you're compiling, because you might be passing it from all sorts of different places. So dealing with the case that the values that you're sending to that command are not known, it won't blow up to be like, well, you passed in the wrong thing.
And there's no exception thrown in Go. The only thing you can do is if you send a panic, which will kill the program essentially. So there's no exception that can be thrown from the code at this point. Maybe go to a half-life.
Yeah.
So, yeah.
Still under discussion.
So there's no, from here, it seems like there's no warning or no message
Yeah.
I thought there was, but maybe I'm wrong. Because I know it definitely. You could, I guess the way that you could do it is you could look for. So do you want to know if it existed before you deleted it, or that it is wrong? Because you could. Yeah, but you could look. Yeah. You could immediately look for the key value pair in your map and verify that it's there after deleting it. And that will return the second value is Boolean as to whether or not it exists. That I know. Yeah. Human error is very difficult to decipher.
You mentioned that the keys in a map could be keys in a map as the key in a map.
Yes, you can nest map into maps.
That's freaky.
Its own, like a map as a key for its own self. Or was using it.
That doesn't.
Oh, okay.
That doesn't seem like a good idea.
I don't always feel like good ideas.
I can give it a try. See if it works. Abraham.
In the spirit of because we can, let's try.
Let's see if compiler complains about it.
Oh, yeah.
So when you declare a map, you always use the make function to allocate the memory space for the map. So Abraham, you want a map to be the key, right?
You want menu to be the key? Oh, you
so
want
something like
Right.
invalid okay, so invalid map key type. Then seems like it.
Do you need another set of? Don't you need to make the next map, like inside of the map? Like it's a double make map, and inside of the map you make the map.
I don't think so.
Okay.
You can because this is simply just declaring the type out of memory here.
Oh, one thing that is good to mention right about now is we were very heavily considering having an entire GDG session being a Go hack session, where we're looking around at people's code and all of the crazy things that we tried, including potentially this, and then talk about the successes and failures that each of us have, because it is new enough that playing around with people that might be going through the same issues might be useful. So, just, yeah.
Menu is a value there. So
That's true.
I guess we can try and see if it works. Something like menu. Does it compile?
It still might not have.
So invalid.
Yeah, this is why we can't have nice things for us. No, I do. The one thing about Go that you'll find is that there's one really correct way to do things, and your way is probably wrong. Which is good because there is inordinate documentation of best practices for Go, including the entire Google Go code review document is an open source document. It's available. So if you want to know the best practices of using the language, they are open and available to you. They are also sometimes very difficult to think about and do correctly.
All right, satisfied?
Yes. Well, we keep trying to do this, but it seems like we might want to talk about struct.
I'm satisfied to the extent of my current Go knowledge.
Okay. We leave that as an exercise for the reader. There's so many puns, by the way, with Go.
So next thing
There's
was
so many.
Keep going.
Oh, don't go there. All right, yeah, let's just talk about
Let's keep talking about it. So there's no class like Java or C#. Instead, we have struct. So again, struct is simply a collection of variables. And again, the capital letter stands for that this variable can be accessed outside of the struct with outside of the package. So if within the package, if I have something like date of birth, which has times here, this date of birth can still be accessed within this package, but will not be accessible outside of this package. So when you create a struct, you do not necessarily append any of this. You do not have any like method associated with. So when you declare a method, you declare that outside of the struct. So there are two kind of methods that you can declare for a structure. So the first thing you declare that does not require a pointer, such as self-introduction, print out the values within the struct. Does not alter the value within the struct, it just simply print it out. So there's no write action towards the struct. However, if you want to change the value, such as the next function, aging, if you want to change the value of the struct, you have to tell the compiler that you're writing it back to the memory address of that struct, which in this case use a pointer to alter the original value, because this is passed. If you do not have this pointer sign, which is an asterisk, you are passing this variable, color variable, as a value instead of a reference. Okay, thank you.
The compiler will complain if you try to mutate something that is not perfect with an asterisk. Or does it just do it like internally to that?
It will alter the value that you pass. So if I remove this one, if I remove the asterisk, so this will make a copy of the context, and then it will modify the value of that copy. But once the function is returned, that copy will be erased, and the original value variable is not altered at all.
Yeah. So in this case, when this function isn't returning anything, that's not really that useful.
But this is a great way to kind of enforce a functional pattern where if you just everything just takes it in as a you can modify it how you want inside, but then everything will have to get
And it's outside of the scope of today, but that's where interfaces go.
So when you design a method, you need to think about whether or not you're going to alter the value within the original struct. If you need to alter the original struct, you need to add the function pointer to the declaration. So in this case, when we instantiate a new structure object, we can just declare it literally like this. So we have this field name, and we add the value at the end. So in this case, we declare a new structure called myContact. It has the value with the name Bob Smith and age 22. And when the object calls self-introduction, it will print out its name and its age. And when we do the aging, it will alter the age. And when we do the self-introduction again, it will give you us the new age. So let's try it.
This is Bob before and after he reads the go-to proposal document. For me, it's not that bad.
Oh.
I think you changed your.
Did we?
Yes.
We took it out.
So we took it out.
Proved us right.
We took that pointer out, and as a result, we did not get the value change at all. So so if we add the pointer asterisk back there, and do it again.
There we go.
Now we get the correct value.
Yeah. Oh, what's that?
The printf statement is inside the function, right? Why
Yes.
didn't change it? Even though you have your pointer there. Oh.
Yeah.
Oh, it's two different.
Yeah, because it's two different functions, we're passing it in. Yeah. Okay.
Yes.
What's the syntax? I see there's no semicolon here. I got the line ending. How do you wrap a line?
There is no semicolon here, and semicolon is optional in most cases. I believe the linter will complain to you.
I don't know if I've ever tried to write a line of Go code over 2 lines.
Yeah.
Because I don't think they strictly enforce columns as far as the length of your file.
Like for example, your printf line is too long and some of it is off.
Oh.
If you wanted to split that into 2 lines.
So something like this, it will still compile.
I think he's looking to actually.
So it's just contextual.
Yep, and you can concatenate different strings together. So you can take a string as long as it needs to be, and then concatenate the string next to it. There's 2 ways of doing it. One is comma separating it, which automatically gives it space between. The other one is the plus sign, which sticks them together. So
For long string?
yeah, for putting strings together.
Okay.
So as long as you know which one you're doing, but that's in print line instead of print f. So that might not work here because printf usually is I'm referring to stuff, and next comes the values that I want to put into the string that I just made. So that might not work as well as in a print line statement, which is just strings as many as you want to put in.
You partially declare your struct, so you put both the name and the age in the initialization.
Sure.
Of the
Okay.
contact down below. Do you have to initialize all of the fields?
You don't have to. So if we do something like this, and then the default value for integer is variable.
So when variables are made, there are definitely default values if you don't assign them. Int's the big one. Ints are 0. Strings are an empty string.
Yeah. Boolean, I believe is false, but maybe
I don't know for sure.
So if it's a pointer, it's a nil. So there is nil pointers. There's no node. There's nil.
Yeah.
For pointers.
NIL. That took a while to get.
And if you do get a no pointer, well, equivalent no pointer exception, like in Go, the program will crash. So just like it's a runtime error. So, and there's another way you can instantiate this contact is by using the new function. So another contact one will be something like new contact. And then another contact will self-introduce itself.
That wouldn't be a very interesting person without a name and the age of 0.
So there's no name, and there's what there is. Oh, yeah.
Is that equivalent to this contact over vertical?
The first one gives you a value, and the second one gives you a pointer. So the new function gives you a pointer to the contact.
Oh yeah. So one other thing we wanted to, or did we want to hit structs anymore?
I think we're good on code. I think.
Yeah, I think so.
Sure. Let's go back to the slide. One more thing to go.
So yeah. So after talking about how awesome all the things in Go are, we figure we might want to talk about controversies and things that maybe people don't always agree on with Go. I talked about a little bit of this earlier. The succinct programs in idiomatic Go. Go is a very opinionated language. There's actually something called Go format, Go FMT, that automatically formats your code. So tabs versus spaces, no, just Go format. Like there is a right way, and just run the thing, and it'll be right. I don't remember. But I figured that if they have an opinion, that I don't need to. So yeah, there's no implicit type conversion, which can be annoying. The concept of objects and classes is very familiar to other object-oriented programs that doesn't exist here. It forces you to think about it differently, which is the point, but also is a pain in the butt. There isn't really inheritance. As of Go 1.11, generics don't exist, although now, because everyone was complaining, they're thinking about putting it in Go 2, which puts them in this weird place where like they didn't have generics, but now they might have generics, but there was a reason to not have generics. And, it's a big argument. But yeah, and the other thing is if you're coming from higher level languages that don't have pointers, getting used to pointers, if you're not used to them, will be an adjustment. And it's part of the language, so embrace the struggle, but it is part of this language. That's just part of learning Go is being comfortable with a slightly lower level view, and a slightly more critical view of the code that you're trying to write and the things that you're trying to do. So yeah, at that, yeah, you can talk about resources.
So here's a list of resources you can use to learn Go if you want to go deep into that. If you want to do the programming part, VS Code is a great option. Atom works. IntelliJ, it used to have a Go plugin, but I don't think it's available anymore these days. They are forcing you to use the Golang, which requires you to pay some subscription for it.
It's not as the Golang doesn't cost as much as some of the other ones, but it still is like $100 a year, I think.
And then for the books, so there's one book that is, if you haven't seen it before, it's the Go programming language book. This is pretty much the ultimate reference you should have for Go language. Although the official documentation is probably much up to date and on Go for the latest versions. Well, the good thing is for Go is it's always backward. At least for Go 1 releases, it's always backward compatible. So if you have a program written in Go 1.2, it can still be compiled in Go 1.10. And there are people that you should follow if you want to go deeper into Go, so such as Rob Pike, Matt Ryer, and Dave Cheney. Those people, they have very great, awesome blogs on the internet, and it gives you a lot of ideas of a lot of tricks in Go that can really simplify the programming part. So they actually, Matt Ryer is probably my favorite. He has quite a lot of tricks in Go that really simplifies a lot of problems, such as especially like function wrapper and decorator patterns. And for the website part, golang.org is the official website for the language, and they have probably the best examples as well on golang.org, and Go by example as well. They also have a lot of examples, very beginner friendly, to show how to write very simple Go code.
Nice thing about Go is also both of those sites have a run code in the browser option, so you can run a Hello World app straight from the Golang website, which is nice. Even though installing Go and getting it to run isn't impossible, it also you can do it in 0 seconds by just doing it from the browser, which is nice.
Yep. And it's called Go Playground, I believe. Yeah. The website you can try Go without installing Go on your local computer and compile it run in a simple way. Communities, I personally recommend Reddit and Google Group, because they're much more friendly than Stack Overflow. If you ask a question on Stack Overflow, you're going to get a lot of shaming. But if you have a simple question and want to ask someone, go on Reddit, people there will help you.
They have a Slack community. I joined it. It was a fire hose of activity. I wouldn't say that people were unkind. It's just so much stuff was going on that it just was, I could never keep on top of
it. If you're into any conferences, so in North America, there is GopherCon, which is in Denver, usually at the end of August. So, and then there's a Gotham Go, which is in New York City. And I believe there are some conferences in London, but it's very huge in Europe. as well.
I think GopherCon is the biggest and oldest.
Yes. And the last thing is, if you have any questions about Go, feel free to ask us. And the code in this presentation is in the GitHub repository. And I'll send you the link to Pearl, Abraham later. If you want to contact us, reach us, feel free to ask any questions. And thank you for coming today.
Where people in this community